Okay, morning folks. This time around we're here closing on sets. So you can see on the thumbnail there, it says A, B, and C, and all the three, they overlap or intersect to the common point, which is green. Let's try and have a look at the proper concepts within our guide and see how best they can be informative. Right, now the topic of interest right here, we have union of sets. So I'm just going to bring in a bit of some sketches here to say, if we talk of union, I've got two sets, I can call them A, B. And if I want union, I'm interested in everything that's covered in between the two sets. Well, below, if they say intersection, so this is union. And if I talk of intersection, intersection is the overlap. I've got sets A, B. When I say interlap, it means I'm interested in just the shaded green part, which is denoted as A intersection B. Then when I say complement, for instance, I've got two sets, set A and set B. Then I come to say I'm interested in the complement of A. So if I want a complement, in other words, I'm interested in everything that's outside A. So that shaded part is what's outside A. Venn diagram is when we put our sets of interest inside a rectangular box, which we call our universal or mother sets. Right, so we are expecting to be able to define a set, a universal set, union, intersection, complements of sets, and as well as representing operations using Venn diagrams. We're also interested in solving problems involving two-set Venn diagrams. Also, we look at typical questions that we might be examined on. Right, so the union, like I gave the symbol earlier on, when we say A union B, we're interested in all that's contained in both sets A and B. And the intersection, here we are strictly interested in what's common in either sets. Then the complement, we are saying we are not interested in what's found in a given set. For this case, is set A. Then Venn diagram, we are saying this is the rectangular container which carries all the sets of interest within our mother diagram itself. So as usual, we are going to the class activity questions. Right, we are given two sets now. We're interested in the union. So the union in set notation, we are going to say A union B. This is defined by, if we look at what's common, we read it once. So this is going to be counted once because it's common. So the elements are going to be 1, 3, 4. Oh, there's a 2 there. Sorry. Let me erase this and redo this a 2 from the second set, 3, 4, and 5. So that's the union. Count the elements once if they are repeated. Then for the intersection, we are strictly looking at what's common between the two sets. So if I look there, what I cancelled was what was common. So I have only one element, which is 3. So the intersection divided by the only element, 3. Then here we have got a universal mother set, which is made up of elements 1 up to 10. So from our universal set, we are saying this consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then in set A, this is what's found in set A. We have got 1, 4, we've got 6, and we've got 8. Then, if we say A complement, in other words, we don't want what's found in A. So all those elements without a red mark, we are looking for them in the complement. That's 2, 3, 5, 7. Well, not 8, was 8 is the complement. So we'll move to 9, then 10. So that's the complement of A. Then moving to number 4, given A and B there, we're interested in the union again. So as usual, A union B, if we want to list the elements, we're going to try and eliminate the repetition. So if I check C is repeated, then the rest they're fine. So in the first set, I've got A, B, C, and in the second set, I've got D and then E. So the repeated element is counted only once. Then next we want the intersection. In other words, we're looking for what's common between those two sets. And if I look at the common elements where I marked one, it's only C that we found to be common. Still moving, I've got a universal set there with elements, elements A, B, C, D, E, F. But well, in set AB, set A, we've got elements B, C, sets, and so what we want here is the complement of B. So complement of B, in other words, we are canceling all the elements that are found in B. For instance, here, we don't want this, right? And E, we don't want this. And then F, we don't want this. So the rest, we want it. But remember, B is appearing in both A and the universal set, so we can also cancel it because it's common there. Then we can now come to say, but B complement is defined by A, B, and G. Right. So that's it for B complement. Still moving, in a class 12 like maths, 15 like English, 5 like both. Find number of maths union English. So maths union English. So we are saying there are 5 who are found in both. So what we'll do is 5, they appear here and there. So it's a repetition. So in one set, we have to remove 5. So our mathematics now is going to say, if we are to bring it algebraically, it's going to be 12 plus 15 minus 5. And when we do so, I'm sure the union has got 22 students. Then here is a true and false. A intersection B includes element only in A. Only in A. So this is false because the intersection, it includes common between both sets. Common between A and B, not B only or A only. Then 9, we are on drawing a Venn diagram. We are interested in a Venn diagram which shows A intersection B. So our Venn diagram is going to be rectangular shape like we said earlier. And we try and inspect, we can see that 4 is found in either sets and 6. So if we draw our sets, it's going to be set A, set B. So I can say A here, B, and the only element outside the intersection is 2, but then 4, let me do it this way, 4 and 6, they'll be found in the intersection. Then in set B, it will only be 8. So that's our Venn diagram there. Let me do it properly here so that we don't confuse each other. I'll do it in a larger format. I have A, I have B. So here I've got 2, there I've got 8. So here it will be 4 and 6. That's the proper Venn diagram for the above problem. Then shade A, complement on a Venn diagram. So if I've got a Venn diagram, which is a rectangular shape, say we've got 2, because we're told to look at 2 sets within a Venn diagram. Say they overlap. If I want a complement, I'll shade everywhere excluding A. So all this is the complement of A. I think basically that's it on closing of our sets under Form 1 CIE Mathematics. Thank you.